Okay, we can also use this rule to prove differentiate inverse function. So let's have a look at, let's say we got y equals arc sine x. Now that's the same as y equals sine inverse of x. Now if I want to differentiate that, it's difficult at the moment, so what I'm going to do is the inverse of sine, I'm going to take that to the other side and sine both sides, so I get sine of y equals x. Now you can do it straight from there, but sometimes I know you like to prefer to write it like this. So x is equal to, so I'm just going to put a, we're going to use this later. So x is equal to sine of y. So if I now go and differentiate this, which is dx dy, I'm differentiating this with respect to y. So differential of sine, sine goes to cos, and that's y. Okay. Now I initially had this y equals arc sine of x, and I wanted to find what the differential of that inverse function is. Okay, dy dx. Now with my rule, I know that I can use this rule, 1 over dy, sorry, I need to use it, I want dy dx. Can I just put the right notation? That's going to be 1 over dx dy. Okay. Same rule, but just flipped over. So dy dx is going to be 1 over dx dy. Once I switch those over, that dx dy, which is there, is cos. So that's going to be dy dx. It's going to be 1 over cos y. Now, I've done dy dx, but it's in terms of y. So I need to put it in terms of x. So now, how do I put that in? I know from my identity that sine squared y plus cos squared y is identical to 1. Furthermore, I also know that sine y is x. So if I replace sine y squared with x, that will give me x squared plus cos squared y is equal to 1. Take that to the other side, that gives me cos squared y is equal to 1 minus x squared. And I want cos y, that is the same as 1 minus x squared, square rooted. And now can replace cos y in terms of x. And that will be 1 over 1 minus x squared, all rooted. And that is the differential of sine inverse function. Job done.